Hi YouTubers, welcome back to the channel. Thanks for joining us today. We're having today a Q&A. So welcome, this is Mali. He's going to help us with the Q&A.
Yes guys, there was a video that we made. Please go and check it out. We discussed the DIY option of turning a bar fridge into a camping fridge. So there was a lot of questions and we're going to try to answer your questions the best we can.
Okay, so 12 years ago I started with this concept of going on holiday, but I didn't have the funds to buy a nice big fridge, camping fridge. And I decided to take a normal little bar fridge that I had and convert it into a camping fridge. So what I've done is I've changed the fridge to lie down on its back and then lie horizontally, and then at a later stage I put an inverter on it to run off my car battery. So today we're going to answer all your questions on what you asked in the previous video. If you haven't seen it, go subscribe, like, check it out. It's on our channel and we'll answer all your questions.
I will put a link to that video in the description as well. Okay, the first question that we had is what kind of fridge to buy?
Okay, so what kind of fridge? Buying a normal little bar fridge, I think they're all 90 liters or 110 liters. And then making sure it's a R600A energy rating, which means you'll have a more efficient gas in the fridge that have an energy rating of A or A+. So if you have an energy rating of A, it'll be efficient. And if you go A+, A++, and A++, it means that the fridge itself is better insulated.
Okay, well, just a question from my side. That little very small fridges, can it work as well?
It will definitely work as well.
Okay, the next question that we had was why is the difference 15,000 Rand for your let's call it professional camp fridge versus the one that you've changed, which is 2,000 Rand?
Obviously the 15,000 Rand is purposely made for camping. So I think being a small company building little camp fridges, you have to sell that fridge for more profit. So doing less products, you have to sell it at a higher profit. And that means that you're going to have to sell that fridge at a higher price. But in actual fact, if you open that camping fridge, it'll have the same motor inside
The compressor,
as what the bar fridge will have.
Yes.
And then obviously that camp fridge is purposely built. If you look at the enclosure on the outside, you'll see it's a stainless steel fridge instead of this painted normal steel.
Yes, obviously the stainless steel will obviously increase the price on it. Obviously it looks good, it comes in a bag, but obviously you can make your own bag for your DIY fridge as well. Exactly. One of the questions that I had personally was, one of the guys had a concern about bumpy roads, the compressor and the motor bouncing around. In a future video, we will show you, we will open up a compressor and we will show you what it looks inside. It is built for this because remember, the camp fridge, the original camp fridge, has got exactly the same compressor and motor,
exactly.
and it's rated for it. It can handle it. It's built for it.
So one of the questions was, why is the motor clunky?
Yeah.
So I'm going to give you a basic illustration on a sketch of what that motor looks like inside. Like Mali said, we're going to cut one open and show you exactly how it's built in a later video. So let's look at what your motor looks like. So you've got the motor housing. So if you look at from the side, you've got a motor housing like this, and your motor sits here inside. And basically the motor has got 4 feet that sits like this inside a channel with some springs. So you've got a cross section of the motor here. The motor is sitting in here. So there's 4 springs. Now why it's got this is because in your home fridges, you don't want a fridge when the motor starts up and it basically moves the whole fridge.
Yeah, it's
in
torque.
That,
I mean,
torque
momentum,
that it
yeah.
starts with. So that's why they did put it on springs, to keep it from moving when the motor starts up and making a noise when the motor
Obviously, it's
starts up,
sound damping, vibration
keeping
damping.
it quiet. And that's the reason when you do transport this in a car, this motor goes and it clunks on the side of the housing, meaning that it's movable inside the housing, but it doesn't mean that it will break in any case.
Yes.
That's just clunking because it's hitting on the sides. So that's no issue at all when you're transporting it like that. And also thinking about since the 80s, the caravans, all of them has got fridges in them. So
Yeah, but usually those fridges was the gas, the 12 volt and the 220.
and the 220
But
volt.
was the compressors the same, or was there some difference?
Similar to this.
Okay. All right, the next question that we had is the gas that runs the cooling side of the refrigerator, which obviously the compressor moves around. Is it flammable?
R600A is a non-flammable gas. So if anyone tells you that it's flammable, it's not flammable, unless it's mixed with air under combustion and it's got a what you call it, a strong ignition source that makes it flammable.
Okay, to be honest, the only reason the gas will come out of the fridge is if there's a damage in the pipeline. So even inside the fridge's frame itself is small pipes, and obviously the pipes leading to the motor, the compressor. I mean, if that breaks, there's no flames or
Close
explosions or anything like that in any case.
by, and it only uses about 15 grams of that gas.
Yeah, that's not a
So
lot.
as soon as it leaks out in the back of your ute or your vehicle, that gas will just evaporate,
just
because the boiling point of this R600A gas is about minus 54.
Yeah.
So anything above that, it'll just evaporate.
Okay, we had a question. Someone asked, why do we use that gas?
The R600 is the most ozone-friendly gas. So they do update it with time. I know the newer aircons also is starting to use now the R410A gas, which is a more efficient. It uses less energy to cool down.
Okay. One of the questions was a very clever question. Why not keep it in the vertical position, and why do we put it on a horizontal position?
Okay, keeping it vertical, by all means you can do that. There's no issue with that. I see in the Australian market these days it's very popular to have an upright fridge in the back of your ute. The reason why I did this is because this is already a cheaper version of a camp fridge, so it's got less insulation. So you want to keep it as efficient as possible, and to do that you turn it horizontal. In that way, as soon as you open the door of the fridge, the cold air stays in the bottom of the fridge.
Yes.
So if you've got a vertical fridge and you open it, all the cold air will rush out the bottom and your fridge starts working again. And that's one of the reasons keep tilting it over horizontal. And then another reason for that is because these days all your standard fridge slides and setups is built to a standard size fridge, and the dimensions of this fridge lying on its back is very close to your standard 90 or 110 litre camping fridges, which means you'll be able to put it in a newer trailer. If you've got a trailer or a setup in the back of your car, it'll fit in a standard purposely made camping fridge.
Well, obviously, with your advice, I converted my own fridge about 3 years ago, I think. And I decided to put it on a horizontal position as well. The reason for me was because I don't want my trailer to be too high. I save a little height by putting it on his back. Because if I put it upright, again, as you say, you will lose a lot of cold air and stuff like that. But for me, it was functional to put it on his back to save height. The second reason is if you put it upright, obviously you need something to close it so it doesn't bump open and everything falls out. So obviously if it's on his back, that won't happen. So it's efficient for me. Like for instance, with my fridge is different than yours because I've got a total separate compartment for freezing and a separate compartment for the fridge side. So sometimes I go to a place, I don't have the 12-volt system in my trailer yet, so I do not have an inverter. So sometimes I just go away for the weekend to a place where there's no power off the grid. So what I usually do is I just buy 1 or 2 bags of ice and I put it in the refrigerator side, and it will keep for 2-3 days easily.
Without running.
Yeah, without running. I mean, it's a cooler box.
And then another thing is what makes it nice is I went to the local hardware store and you buy these little cupboard lifts that you use for vertical lifting of cupboards, and I put it in the door.
What do you call it? Struts, I believe.
I think it's a strut or something. And to make it easy, when you open the door, that little strut will then just push the door open, so you have no worries keeping the door up. And that makes it even a little bit, I think, better than my 15,000 Rand fridge.
Well, in fact, with my fridge is the angle that I place it in. If you close it, it keeps it closed. Then you have to physically break that to open it up.
To
so
open
it won't.
it up again.
I never had, and I traveled on some rough roads. I never had, when I opened my slide out, that one of the doors was open. It is always closed.
It's always closed because it just falls closed.
Great. The next couple of questions that we have is, what's the pros and cons on this fridge versus expensive one that you buy?
Well, obviously, firstly is the cost. This 2,000 Rand versus 15. And then the pros on this is because you paid so cheap for it, you don't feel guilty when you bump it, or you're not crying when you bump it, because I'll definitely, if I drop my expensive fridge, I'll have a little tear run down. And then another thing is the expensive one, it's purposely made, so it's got better insulation than this. Definitely you'll have more efficiency keeping stuff cooler for longer in the more efficient one. But again, price wise versus this, you'll basically save on cost.
Well, from my personal experience, I was at one of our local dams in December, and it was quite hot. I mean, South Africa has got nice and hot summers, and we are in the Northwest Province, which is even one of the
which has
the
got
hotter
summer
ones.
in the winter.
And then I used it on power, obviously, and a little problem I had, but it was a little silly mistake, is the regulator where you change the thermostat. I believe someone just bumped it, or even myself bumped it with a cool drink or something. Then I accidentally turned it up to its highest setting, and about 3 hours later, the stuff inside the fridge started to freeze.
It froze everything inside.
So I don't think that insulation is a problem, but again, mine is a double A fridge, so it is a bit thicker insulation than yours perhaps. But in your case, any problems with insulation?
Not at all.
And I mean, you've been to Namibia, and
It's been all over. Took it right up to Mozambique.
yeah, it's
And I've got it now 12 years running like that.
hot. Okay, so on that, another thing is how to make it more efficient. Keeping on that.
I think the only way out, are you going to keep it more efficient, is to keep it horizontal, like we explained earlier.
With the cold air rushing out, yes.
Keeping the cold air inside. And then also what I've done is, we'll show a photo right now of, I put a 220 volt computer fan on the side, so that as soon as the motor switch on, it switches on the little fan, and the little fan just circulates cold air from outside over the motor.
But is it necessary?
Not at all.
Not at all.
It's just, it'll help you maybe a 3% more efficient if your motor runs cooler.
Okay, but then another thing that we've discussed is if you make a canvas bag or something like that, with
also a possibility.
with a foil insulation or a polystyrene between the bag and the fridge itself. I don't personally think it's necessary. Well, obviously you can protect your fridge
You will.
against bumps and scratches, and then obviously it will be a little bit even more efficient.
And it'll look like a camp fridge.
will
It'll
look
make
like
it look more like a camp fridge.
But just keep in mind, if you do that, where the motor is situation, put a opening there or a
Netting
glass or something, because you need ventilation on the motor. As you said,
Definitely.
it needs to breathe. Even your, as you said again, your expensive one has got exactly the same compression,
Exactly the
with
same.
again with a opening there.
At a later video, we'll also show you on the more expensive fridge how to do a problem diagnosis. So I've got a good friend that showed me how to do a diagnosis to see what's wrong on your expensive compressor if something goes wrong on those fridges. So in a later video, we'll show you how that's done.
You better hit that subscribe button and the bell, not to miss on that one.
Yep.
The next question that we had was, you put some kind of coating on your fridge. What exactly is that on the outside?
Yes, so basically I went and I bought one of these. It's very cheap. They call it a Duram 88 here in South Africa. But you can obviously coat it with any Bucky lining if you want to, or Ute lining. I see these days you get these Raptor coatings, which is actually super strong. So if you're willing to spend that money, go buy it. Here in South Africa, I think I paid 90 Rand for 1 liter of that stone chip Duram 88, and I just coated it just to make it look like a camping fridge and give it that rugged look.
Yeah, I don't know what stone chip is called elsewhere in the world, but yeah, in South Africa, just to explain it quickly, it's a water-based, thick water-based paint, where you can splatter it on with a special gun to give it a rough look, and again it helps to make it a little bit more insulated and it looks nice.
And it looks like a camping.
If you scratch it in the future, you just give it another coat.
Another coat and it covers it.
Quick and easy, no problem.
You can also cover it with a little sponge roller if you want to. It gives it also a nice smooth texture.
Or if you like, you can get a camo wrap and wrap it.
Wrap it.
All right, something for the guys. If you're a Toyota driver, you can maybe wrap it in Toyota or
that's it. Put a logo on it
VW or something.
if it needs to.
It's yours. Do whatever you want. It's not 15,000 Rand. No.
You don't mind.
All right. The next one that we had was someone mentioned with my fridge. I will just show a quick picture. The inside of the door has some cubby holes or whatever you need to call it.
Holders, milk holders.
Yes, where you can keep your milk or your jam or whatever in the door. But obviously, if you put it on its side, then if you put a 2-liter bottle, it's in the way. So I just cut mine off and I'll address it later. So it doesn't look that good, but it's working for me.
I only just took it off and I cut a piece of plexiglass or perspex or something. And you just put a big piece of panel in there. There's no electronics or anything in the door. Yeah. So by all means, you can take a grinder and just cut it along the side and take that panel off. It's got some foam filling inside, but you can just cut that with a knife or anything.
Well, I saw in yours, you've got this little battery-operated light that you said is made for cupboards, and that's very nice.
Some of these little bar fridges doesn't come with little interior lights, so I went and bought one of these cupboard lights. So you get a cupboard light that fits onto the hinges of cupboards. When you open the cupboard, the light goes on, and I just fitted that into my fridge. As soon as you open the lid, the little light goes on.
What I like about that one is battery operated, so there's no need for wires or drilling holes or anything like that. Just remember, guys, if you put it on its back, but again we will get a fridge, we will do a DIY with you, show you exactly how to do it, how we do it. Remember, we are not professionals again. We just show you how we do it. You can use your own ways on how to do that. But again, like mine, for instance, I had to put some little pedestals or feet, what do you call it? So I had to make some holes in the fridge. So before you drill, make sure there's no pipes inside there.
Exactly.
Because if you damage that pipe, you will definitely have a problem.
Exactly.
So just be careful of that. Fortunately with mine, it came with a light, so I didn't have that problem. But if you want to be fancy and you want to put a whole LED strip, it's your choice. It's your
choice.
fridge.
It's your fridge.
You can do whatever you like. Okay, the next one we had was your fridge has got an inverter built into it. Again, now some vehicles has got the inverters in the vehicles, and so you can just plug into your inverter directly with your 220 plug, 220 volts plug.
Yes.
But you decided to put the inverter in. Why?
Inside. The main reason is because I've got a camping fridge at this stage, so I don't use my inverter anymore for running only my fridge. And the reason for that is I've got it lying there. Why not just put it in the fridge and you can just plug your fridge in your 12 volt system?
Yeah, no, because when we filmed your fridge, it looked kind of strange with the plug there, but you have explained it quite well.
Also, what's nice is when you do need that power, you can plug your drill into your fridge and you've got power backup with you.
Why not?
So you don't need to have a separate inverter in your vehicle.
Well, I believe if you put like that Anderson plug you've got, this is just an idea. If you get another piece of it with 2 clamps for your battery.
Exactly.
In South Africa, we've got something called load shedding. The rest of the world, if you don't know what it is, sometimes the load on the grid is too much, so they switch some suburbs off for about an hour or two, depending where you live. So it happens that we get stuck without electricity. So to add on to that one, if your inverter is strong enough, you can put on your TV, charge your phone through your fridge. So going on to that question, what we first need to find out is what type of inverter do we need and what size inverter do we need?
Okay, the size of inverter. Let's start with the size. So this fridge, when it starts up, it uses quite a substantial amount of ampage that it gets the motor turning, and that ampage your inverter needs to supply that ampage. So as I worked out on these little fridges, your nominal watts on your inverter should not be less than 800 watts. The maximum power rating on that would be about 1600 to 2000 watts. That's meaning that as soon as the equipment kicks in and it takes a lot of ampage, the wattage will carry that ampage. But that maximum wattage only means that it'll carry it for 3 or so seconds.
Okay, just to cap on that, what is the size inverter on your fridge currently?
Currently I'm running a 2 kilowatt max inverter that's giving me 1000 watts. So the draw, when only switched on the inverter, the draw that it pulls out my battery is about 1 amp when it idles, or when it's not in use, when nothing's plugged into it.
Yes, we will do a test later on just to verify the amps and the watts and everything we need to for that. But again, the type of converter, is there a specific type?
Yes. In South Africa, most of us only know about 2 types, which means you get a modified sine wave inverter and you get a pure sine wave. But actually, the older types was called the square sine wave. So I'm going to keep it basic, but let me explain to you the 3 types of inverters. Okay, let's look at the 3 types of sine wave inverters you get. So firstly, you get the square sine wave, or the older terms they used to call it a square sine wave. So basically you've got your time, this is your time graph, and this is your power graph. So on your power graph you get your direct current input that's basically lying on a line like this, and then you get your sine wave that you'll get off the grid. So the grid will give you a sine wave almost like this, going up and down. So your square sine wave will try to mimic this to give you the best flow on your AC motors. So in the old days they'll use the square sine wave, meaning that it'll shoot up in voltage and then drop down in voltage, trying to mimic this perfect wave. So you'll get something almost looking like that. Then on your modified sine wave you'll get the same setup, the modified sine wave will basically try to mimic the same line of pure sine wave line that you're getting off the grid. So what your modified will try to do is it'll keep it on a volt and then jump up to a certain voltage and then try to keep on that wave, then come back, then try to keep on that voltage, try to mimic that wave. So you'll get almost a pattern looking like this. And that means, what this means is it tries to simulate the sine waves. So looking at this, using this modified, you can use this. This is not an issue to use on a motor. Anything with a motor that turns is not an issue to use this. What you'll get on some electronics is you'll see some of the electronics gives you some noise. Sometimes it's because of this wave trying to mimic the sine wave. Then on your pure sine wave, which is actually, they shouldn't actually call it a pure sine wave because that's what you're getting off the grid. So a pure sine wave, when you look at the wave a pure sine wave does, your pure sine wave will try to get much closer to this. So it'll give you small little jumps in power to try to get as close as possible to this. So this is more like a, how can I say, a try to mimic the sine wave. So you'll get more of this. And that's why some of the equipment, you can use this on more of your microelectronics, laptops and stuff like that. The reason why it does this is to mimic it as close as possible, but also this comes at a cost. So you'll easily pay double the amount for pure sine wave compared to a modified sine wave. But there's no reason why you cannot use the modified on your camping fridge.
Obviously, as you say, it's a cheaper option.
Yes.
So it will not damage your
It won't
fridge.
damage any internals. The efficiency of a pure sine wave is a little bit better. So if you run it on a fan or something, you'll hear the fan makes a bit of a noise. But motors might run a little bit warmer, but it will run. There's no fact that it'll burn a motor if it's run on a modified sine wave.
Okay, then the next question we have is obviously the cost, all in all. So can we talk about cost in your case?
In my case, I've done it 12 years ago. So that time I bought the fridge for 1,000 Rand. I see these days they're ranging about 2,000, 2,500 per fridge. And then the inverters you pick up from anything from 500 and up, depending on the size you want to put in.
Okay, in my case, what happened is I've got a fridge exactly the same as yours that I've converted, but I didn't do anything to it. I just turned it 90 degrees on its back and mounted the compressor again. And then I needed another bar fridge to replace this one I converted. So I went to one of my local stores and was pleasantly surprised to find the type of fridge. Immediately I changed my mind to swap the fridges around, so I converted the one back, which is very easy. I just took off the base plate of the compressor and turned the compressor up right again and fit the base plate back, and there was no evidence of me ever doing the conversion.
Just to add to that, when you swivel it, just to make sure that you don't pinch any of the little pipes in the back.
Yes, definitely. It's easier if someone can help you. In my case, someone hold the compressor for me as I turn the fridge, and checking the pipes at all times, the wires at all times. Be gentle, take your time. The only thing that I found was with the same as yours, the base plate under the fridge that carries the compressor. If you turn the fridge, it exactly mounts on the bottom again. You have to make no modifications. It is just drilling 4 new holes, using the exact same screws and putting it back. With the one that I changed again, the second one I bought was a little bit different. It seemed like the compressor cavity is not the same upright as it is on its side. So I had to put some spaces in between to drop that plate a little bit to give me some headroom for the compressor. So it only means that I lifted the whole compressor, I think it was 40 millimeters in total, which is not a problem for me in any case.
Okay guys, so let me show you what I'm going to do now is I've got my multimeter set up on the DC ampage. Just a little quick tip, go and buy yourself a nice proper multimeter. You can read all of this settings and everything, and you're sure about all the ampage usage and all that. It's a little bit more expensive when you look at inverter that's got DC ampage and AC. You'll see your standard multimeters doesn't have the DC readings, but this is a bit more expensive one. So let's see, when I switch this on, I'm going to set it here to max, and let's switch on the fridge and we'll see how much power this pulls as soon as the fridge switches on. So let's see, you see the startup ampage on this fridge. So that's a reason being why you need proper cables running from your inverter to your battery. And if you use cheap Chinese cables, it can't carry this power, and your inverter kicks out and tells you that there's insufficient power running. So let's see on standard how much DC amps this will be running. So as soon as your fridge is starting to run, don't worry about the negative. It's either going to show you a negative or the positive. I just clamped it on the wrong cable, but that's basically the running ampage of this fridge when this motor turns. So you'll get about 5 amps that it pulls off your battery, which means if you've got a 100 amp an hour battery on a 50% cycle, then you're going to have about 10 hours of permanent running of this motor. But remember, this motor isn't permanently running, so as soon as it gets to temperature, your fridge will switch off and the motor doesn't use any power. Okay, so what we've seen now is we've done the 5 amp test on this one. So this one is pulling 5 amp, that's the DIY one. So let's see what happens if we put this professional camping fridge into the power socket and see how many amps this is pulling out the battery. So as soon as I plug it in, you'll see it's off. Let's plug it in. This is going to kick in now to maximum DC amps. You'll see this is the more modern camping fridge has got a much softer starting ampage, so it won't spike like a standard fridge. So there's it up and running. So you'll see, so this professional camping fridge is running at about 4.3 DC amps, which means your standard fridge is only using 0.7 less or more than a purposely built fridge. So basically the power consumption is exactly the same. 0.7 amps an hour, meaning that you'll run on 50 hours, you'll run 140 hours, you'll get more with this. Okay guys, as you've seen now, we've tested both of these, your professional one and your DIY one, and the power consumption between the two isn't really major. So seeing of how much you pay for this and how much you're paying for this, at the end of the day I think I'll actually choose this, even though I've got this. even just looking at the weight wise, this thing is super heavy compared to this. This is a much lighter fridge to carry around. But I think at the end of the day, it's all up to you. Like we said, we're not professionals, and this is what we do as hobbies. But if you want to see more of this, in the next video we're gonna do one of these, and we're gonna show you exactly how we're doing this. So like and subscribe this channel. Please help us grow this channel. If you put a like there and you put a subscribe there and you switch that bell on, it'll help us grow this channel and even give you better content. So guys, please like it, subscribe and follow us.
The aim of this channel is to inspire you to get out and do your own DIY projects. We can assist you by giving you information and ideas. All the projects featured on this channel was already completed up to that stage. As we continue with these builds, we'd like to take you along on the journey and even on future builds. Only 18% of everyone viewing our videos is subscribed. So we need your help. By clicking the subscribe button and liking the videos, you will assist us in doing future projects.